All right, hey everybody. So this is chapter 18, Amines. It's a very short section, and it's kind of a lot of uh, stuff that we've already covered, repetition. Like we're going to do nomenclature, which follows a lot of similar rules to what we've done in the past with other functional groups. Um, Quick note about your Alex. So I have reduced the number of topics for some of the chapters. I didn't like chapter 15, the 3D shape of molecules, so I went ahead and pulled that out. You might have noticed that on the announcements. But we had 11 assignment. I think we might have more than that, but I was already planning on combining two sections for your grades. Now it might just work out to where this is kind of an easier section and you can get those points for the objectives more easily. So there's only four topics in chapter 18. I forget what objective it is. Objective number 8 in your Alex. Okay. Another quick note about Alex: you should be able to move around freely. So if something is locked and you can't get back and forth without finishing a section that you're having trouble with, let me know and I'll try to figure out a way to unlock that for you. Alex is really weird about how they do their modules. So typically in a normal semester, it would be you'd have like a week for each section, and at the end of every week, it would close down and unlock the next section, regardless of whether or not you finished that previous section. When I made the due date for all the assignments July 24th, it messed with that process. So it locks an objective until you get finished with the one before that. But that shouldn't be the case. You should be able to move around freely. If you're not able to, let me know and we'll try to figure out a way to open up everything else, okay? So email me, say, hey, I'm stuck on objective one, two, whatever it is. Can you unlock that for me? And we'll try to figure out a way. It usually takes me a couple tries because I'm not real familiar with Alex and it's not very user friendly on my end. So we'll figure it out. Just email me and we'll try to get all the rest of them opened up for you. All right. So, like I said, Objective 8, only four topics, and most of this you've already seen to some extent, with the exception of the nomenclature, right? We just changed the name on a couple of different things. So, change the ending, I should say, as opposed to when we used alcohols, we ended in OL. When we used aldehyde, we ended in AL. When we used the ether, it ended in ether. For the amine groups, we're going to end in, surprise, amine. Okay, and you just put an amine on the end, and the rest of it kind of follows the similar formats to stuff you've seen in the past. Something else that you have seen already is primary, secondary, tertiary. So if you remember the alcohols, we looked at how many carbons were attached to the alcohol carbon, right? And if there was one carbon attached, we'd call it a primary alcohol. If there was two carbons attached, a secondary, and three tertiary. So you're already familiar with these terms. Now, one difference between uh, this kind of nomenclature and the amine groups is that you can actually get four carbons bonded to a nitrogen, and we call that a quaternary amine. Okay? So, something to note about quaternary amines is that the nitrogen group carries a positive charge. Remember that nitrogen likes to only have three bonds. So when you add in that extra bond, it takes away some of the electrons. It shares one of the electrons with another group and causes the nitrogen to be positively charged. So you'll see a positive charge on these quaternary amines. Another word for this molecule is called the ammonium ion, and it's a little different than ammonia, which does not have the fourth, is not a quaternary amine, does not have the fourth uh, attached atom. All right, so kind of be familiar. Ammonium, ending in an M, means that it has that positive charge and it has four substituents, four carbon substituents, but it could also be hydrogen. If you have four hydrogens there, we'd also call that an ammonium ion. All right, uh, but it wouldn't be a quaternary ammonia because the terms primary, secondary, tertiary, quaternary only refer to carbon attached atoms. Okay, so I hope that makes sense. There's a couple of topics in your Alex dealing with that, so you're going to want to be familiar with it and be able to recognize the difference in hydrogen and carbon being attached to an amine group. Okay, now the only other nitrogens that we've seen so far are the amides, right? A nitrogen attached to a double bonded carbonyl. So make sure, let me pull up my paint program. Make sure you get those, uh, have a distinction between those two different kinds of molecules. Remember, amide is attached to a carbonyl carbon, which is that there, right? And we'll just put R over here. So this is the amide, and then the amine just, oh my goodness, I ain't even gonna try to spell it out, but that's the amide, and then the amine, you will not see any carbonyl carbon around, okay? And it's just kind of next to it. So say it was this right here. I'm going to draw just a little bit bigger molecule. Bop, bop, bop. Okay? So this is not an amide. We call this an amine because the nitrogen is connected to carbon atoms, but none of these carbon atoms are attached to a double bonded oxygen. Okay, so this nitrogen here will be an amine. It'd be a tertiary amine. All right, and like I said, I'm not going to try to write with my mouse because it gets so ugly. But that is a tertiary amine. I guess I will because I'm almost there now. As opposed to the last one we saw where the nitrogen is directly connected to carbonyl carbon, right? Doom C double bond O. That is an amide. Okay, so it has to be directly attached to that carbon for it to be an amide. So let's go back to the slides. All right, and there are heterocycles, which is just another way of saying that it's a carbon ring, but it has a different atom. That's what we call it a hetero, is in different cyclic compounds. So different atoms in an organic cyclic compound. And so this happens with nitrogen sometimes, and we just call them, we just end it with INE, and that lets us know that there is a nitrogen present somewhere. All right. Now these have their own kind of names. Um, we'll see that the nomenclature is pretty much the same for standard amine compounds, but for these like cyclic, heterocyclic molecules, you usually have to come up with your own name, a general terminology to be able to refer to it. All right, and I'm not that worried about shape. Remember that including all electronic groups, amines form a tetrahedral, just like a methane would. And then this trigonal pyramidal comes from the fact that one of the electron groups is a lone pair of electrons. So it's not necessarily an atom. And if you're going to name the shape of a molecule, you do so with all the electron groups. That dictates the angles. And then the atoms dictate the actual name of the shape. So for tertiary amines or any amines that are not ammonium ions, it will be trigonal pyramidal. But I'm not asking anything about the shape of those molecules on this particular section. So, all right. And then here's the nomenclature. So you just remove the E, add amine on the end. As we saw in this last section, it's a methyl group attached to an amine. So you removed uh, the ending and then called it methylamine. Trimethylamine, meaning that all three methyls are attached to the amines. You'll see some different examples of that, and your Alex goes into questions about those particular things. So, and then there's another process for naming amines where we add a "n" to let us know what is actually attached to the amine. So for the first part, this is just this will be butane, but since the end of the butane, four carbons, right, is attached to an amine group, you remove the E and add amine, okay? And then you can put the number at which the amine is attached, right? So this would be 1 butanamine. Let's see if they do some more examples. Okay, and then depending on how many groups are attached, you use the same prefixes that we've learned earlier. Tri, di, in certain cases tetra. Tetra would be for 4. And then you just put that as a prefix to whatever the attachments are. So these have 3 ethane groups attached to an amine. So you remove the A and E and put on amine, and it becomes triethylamine. Okay? This amine is a secondary amine. It has 2 propane groups coming off of each side of the amine, so we call it dipropylamine. All right, remove the A and E and add amine. And then, are they going to do quaternary? I guess not. So we'll see if they come back to that. But there is a tetra uh, for amine because we can get a quaternary which has 4 groups attached. And the prefix for that one would be tetra. Alright, so here's the instructions on how to name an amine. You just recognize the longest carbon chain in the molecule. Name it for what it is. So 1, 2, 3, that would be a propane. Alright, and since this is attached to an amine, I'll remove the E and add amine. So propanamine. And then I have to also mention this methyl group. And so the way you do that with an amine is to put it behind an N. Okay? So the other groups on the N as N-alkyl groups, we call it N-methyl 2-propanamide. That should be propanamine. I don't know why they called that an amide. That is a mistake in the slides, and I apologize. I hope all of y'all catch that. That should be propanamine. N-methyl 2-propanamine. That is not an amide. An amide has a double bonded oxygen and a carbonyl carbon, which this does not. So that's a misprint. Make sure you're aware of that. Alright, amines with ends directly bonded in a benzene ring we call anilines. Alright, so if that nitrogen comes off, remember we looked at toluene, which had a methyl group attached and it had its own name. Phenol, which was an alcohol attached to a benzene ring, it had its own name. An amine attached to a benzene ring has its own name. We call that an aniline. Alright. And but the naming is the same thing. If you had something else attached there to the nitrogen, you just say N. Let me see. Here it is. N ethyl. So ethyl group attached to the nitrogen. N ethyl. Drop the ending. Add aniline. N ethyl aniline. Um, there is some naming. Something that we haven't looked at is ortho and meta. That's what this O, and then there's another one that would be meta, and then para, which is directly across, uh, would be a P. Let's see, I don't think it actually goes into that in this chapter, so I wouldn't worry about that, but just in case you were wondering what those little other letters meant, um, it's telling you which part of the ring that this bromine is attached to. Ortho means right next to it. Meta would be two away. Para is directly across. Okay? So no worries there. Just I imagine you can probably skip over that. There might be something in Alex about it, but I don't remember seeing anything. And then, as I said, these heterocycles they usually have common names that are really don't indicate anything about the molecule. You'll just have to kind of know these or recognize these. Maybe have this list there because this is the most popular ones that you'll see. So if you have like a little table with these amine heterocycles on there, that would be fine. Just to be able to recognize it. I don't ask anything on the final about that. So but if you want to be more familiar with it, that's how you can kind of do that. Just kind of memorize them. A pyrrole is a very peculiar molecule that is used in reactions and stuff, but uh, I've never seen it used it in real life. Piperidine, you'll see this in a lot of medications and stuff. Pyridine also. All these are used in the formulation of like medications and different things because nitrogen is a typically very reactive group, and so we can use it to make all different other kinds of molecules. So amines have hydrogen bonding. They can have very foul odors, kind of like the sulfur when we talked about sulfur. And then it's important to remember that a tertiary amine doesn't have hydrogen bonding because there's no hydrogen attached to the nitrogen. So you have to have that hydrogen nitrogen bond to create the hydrogen bonding that helps to increase boiling point or melting point or whatever. And thus, if you have primary and secondary amines, they will have a higher boiling point than a regular carbon chain molecule of the same length. I think alcohol would still have more hydrogen bonding because the oxygen is attracts electrons more. It will have a stronger negative charge. Um, so it does have more hydrogen bonding than amine. This is going to be important. You know how I asked something about boiling points on the midterm? I'll probably do something similar when it comes to amines. So be familiar with hydrogen bonding, how that works. I might even try to trick you and put a tertiary amine in there and say, well, what's the boiling point? Which one has a higher boiling point, the tertiary amine or the primary amine? The tertiary amine, excuse me, the primary amine will always have a higher boiling point because it has hydrogen bonding. Okay, if they're the same size molecule, but I won't make it confusing. It'll be something easy. They'll be about the same molecule. One will have be a tertiary amine, one will be a primary, or one will be a alcohol versus an amine with the same length. This is butanamine versus butanol. They're the same length carbon chain, but there's vast differences in the hydrogen bonding aspect. So the alcohol has a higher boiling point. And then this is what we just said. Tertiary amines have lower boiling points because they don't exhibit hydrogen bonding. There's nowhere for a hydrogen to get in on this tertiary amine and bond to the nitrogen. And vice versa, there's no way for the nitrogen to kind of seek out any other hydrogens and kind of create that little link with the hydrogen. So lower boiling points for tertiary amines than primary or secondary. And then the rest of this is health and focus. Remember, I said that a lot of those nitrogen heterocycles are used in like medications or uh, stimulants or drugs or anything that the body deals with usually has some type of this nitrogen heterocycle. But they all have their own names. Um, So, I mean, like I said, if you want to print off a chart with these different kind of molecules, but they all have common names, and there's no IUPAC nomenclature to kind of just stick in there to be able to name these compounds. We just kind of give them their own names and then have to recognize them from there on out. Okay, I am. There is a lot of extra stuff here. I'm not going into neurotransmitters or any of that stuff. Now, typically, this would be where we'd start kind of doing biochemistry and looking at how these different molecules are used in the body. But as short as this course is, and as much as we've already covered, I'm not asking you to do that on Alex. And I just need you to know what amines are so that when I introduce amino acids, you'll be able to recognize them. Um, but if you want some context, you can obviously go through and read up on all of these different things that contribute to why amines are important. Important. Here's a image of morphine, the molecular structure of morphine, and you'll see it has that weird little shape with the nitrogen in a heterocycle. Uh, that's why I said these nitrogen heterocycles are critical for biological processes. They create all different kinds of reactivity, and they are essential for matching up with molecules in the body. It's important for the molecules, say your T cells, to be able to recognize nitrogen in a compound, or the receptors in your brain. These other sections are neurotransmitters, so the receptors in your brain have to recognize those nitrogen groups on the molecule and be able to process that information. So, nitrogen and its substituents are very important to biological processes, and that's really all you need to know about that. So I'm most concerned with y'all being able to name simple amines, and then being able to recognize whether or not they're primary, tertiary, secondary. Uh, yeah, and that's really all I'm concerned with on this section. Like I said, I'm going to use it going forward for other things, and we will get into more biochemistry, but I'm not that concerned with it as of right now. All right. So I'm not going to ask you anything about morphine or ephedrine or nicotine or caffeine or any of these things that have these nitrogen compounds that the body uses to recognize. Let me just look and make sure I've covered everything. Yeah, yeah. All right. So that's it for today. Like I said, pretty short. I just want you to be able to name and be able to identify primary, secondary, tertiary for this chapter. Um, we only have what three or four more chapters left to go. Three or four more Alex objectives, but we've only got 2 weeks roughly to do it? Let me see, 14 and be 25. Yeah, we've got about 2 weeks to finish all this up. So I'll post another lecture tomorrow, Tuesday, July 12th, for chapter 19. And then we'll start getting into physical chemistry and biochemistry and perhaps a little analytical. I'm not real sure, but we're going to use all the information that we've already learned to kind of move forward and get into some more detailed stuff. So this is more or less a break. You are doing some naming, but it's easy because you've done so much of it already, right? All right, I'm here if you need me. I will see y'all tomorrow. Bye.